So let's move to the problem where we left. I think this was the place where we left yesterday. Right? I think the screen is visible now. So now when we reached at this step, we observed that the number of assignments were 4 and there are 5 rows and 5 columns. So obviously it was not an optimal solution. This is what we concluded. Okay. Now we have to move to the next step where we revise this cost matrix and then continue working till an optimal solution is reached. Okay. So that revision of the cost matrix is done in this step, which is my step number 4. Okay. Now in this step number 4, we'll be now, in a way, what we'll be doing is, crudely speaking, we'll be crisscrossing this cost matrix that we have obtained, where we have allocated zeros and we have striked off zeros as well. So in this matrix itself, we would be drawing certain horizontal and vertical lines which will help us in reducing this matrix, which will help us in not only reducing this matrix, but which will help us in reaching the optimal solution. Okay. Now, to draw those horizontal and vertical lines, there are certain rules that we need to follow. So for that, just be careful, listen carefully, and try to understand what I'm trying to say. Okay. The first step is, that's why, I'm writing this for you all so that it's clear to you. What we do is, for each row in which no assignment has been made. So basically what we are doing is, we are identifying rows in which no assignment has been made. See, definitely we'll find a row because the number of assignments is less. So definitely there will be at least one such row where no assignment has been made. But if there is more than one such row, so what we do is we just identify those rows. For each row in which no assignment has been made, we mark that row with a tick here, just outside that row. Okay, just we mark that row. Now, once you have marked rows with a tick here like this, that means that row becomes a marked row. Okay. Then next, what we do is we examine the marked row. Oh, let me write what I'm saying. We examine the marked rows. It could be one, it could be more than one. So I'm writing examine the marked row or rows. If any zero cell occurs, irrespective of how it occurs, striked off or marked with a square, if any zero cell occurs in those rows, then we mark a tick to the respective columns. So this marking is important because this marking will lead you how to reduce the cost. So we mark a tick to the respective columns that contain those zeros. Let's write these steps and then we'll do it on the problem. Okay. That contain those zeros, right? Now, once the columns have been marked, then again, we examine the marked columns. Okay. We examine the marked columns again. If any, now there's a difference. If any assigned zero occurs in those columns, then mark a tick in those rows, where it occurs. Okay. Now, it could be possible that when you find a column in which a sign 0 occurs, maybe that row has already been marked or something like that. So if it doesn't, then you mark a tick in those rows where it occurs, right? So, I mean, what you are doing is you are starting with rows, marked rows. You are finding any 0 cell. If it occurs there, then you mark a tick to the respective column. Then you examine the marked columns. If any assigned 0 occurs on those columns, then you mark a tick in those rows where it occurs. Now you will get a new set of ticked rows. So we repeat this process because then you've got a new set of ticked rows. That means we can go back to step B where we identify that ticked row. Then we look into those columns and we can repeat this on and on till what we do. So we say repeat the process until no more rows or columns can be marked. Okay, is this clear? Now I will do it with a problem and then we do. And now what we do is, once this ticks have been done, then we draw a straight line. These are the 5 steps that we have to follow very carefully. We draw a straight line through each marked column and unmarked row. So this is important. So we draw a straight line through each marked column and unmarked row. Okay. Now I hope you have all these 5 steps written in front of you. Okay. So we come back to the problem. Now I'll make the table again on a new sheet because I need more space now. So let's go back to the problem where we left, where we had seen that it was not an optimal solution. So I think we had 5 jobs, A, B, C, D, and E, and we had 5 employees. 1, 2, 3, 4, and 5, right? And after making the assignments, the matrix was, just correct me if I am wrong. This was 5, I believe, and this 0 was a marked 0. Then we had 8, 10, 11. Is this correct?
Yes, ma'am.
Right.
Yes, ma'am.
Right. Then in the second row also, the 0 was marked, and we had 6, 15, 10, and 3. Right. Then we had 8, 5. This 0 was marked, and this 0 was striked off. Was that, is this okay? And this 0 was also striked off?
Yes, ma'am.
Yes.
Then in D, we had another 0 that was striked off. 4, 2, 2, 0 that was striked off. 5. And the last was 3, 5, 6, 0 that was marked. And yeah. I think
yes, ma'am. It is not striked off. It is marked.
which one? D4?
Yeah. Yes, ma'am.
Okay. That's what I thought. Maybe I.
And below this, it is striked off.
Yeah. So This was striked off, right? That's what I was thinking. I made some mistake here. This was marked, and this was striked off.
Yes, ma'am.
So we have this case now with us. Is that so?
Yes, ma'am. It's perfect.
नहीं वैसा ऐसे? Are you sure? Let's cross check. Yeah, maybe yes. This. Let's see what happens. Okay. Now we move to step number 4. Okay. Now what we do is we have to, for each row where no assignment has been made, right? Now, if I look at the first row, we have made an assignment. In the second row, we have made an assignment. Third and fourth. It is the fifth row in which no assignment has been made. Okay. So what we do is we mark it with a tick, right? We mark this row because no assignment was made here. Then in this row, I observe that there is a 0 here, right? And this 0 occurs in the fourth column. So I mark the fourth column also. This is what I was to do. For each row in which no assignment was made, we mark a tick. Then we examine the marked rows. If any 0 cell occurs in those rows, we mark a tick to the respective columns that contain that 0. If there would have been more columns, more zeros here, we would have marked that column as well. Now, in the marked column, we see whether there has been an assigned 0 or not, right? So I observe there is an assigned 0 here, right, which happens in the fourth row. Because see, this is what we are doing. We are now examining things here. Okay. For each row that we have marked, we were to look for zeros. In this, I have obtained only 1 0. So I mark a tick here. But when I have marked a column, the zeros that I have to observe are the ones that have been assigned. Okay, there are 3 zeros in this column, but only 1 is assigned, right? So what I'll do is, I'll now mark this row as well with a tick. Okay, now we repeat the process. Now we examine this fourth row for rows. I observe that there is a row here in the fourth column that has already been marked, but then there is a 0 in the first column as well. Okay, so I have to mark this column as well. Okay, once I mark this column, then I look for assigned rows, assigned zeros, I'm sorry. Again, there is a 0 here. So I mark this row. Okay, so what has happened? Now, in the second row, I have to repeat the process again. So is there any other 0 left? No, there is only 1 0, which has already been marked. So that means now I cannot mark any more rows or columns. Okay, see, I'll repeat the process again for you. You work with me now. Again, check how we are doing. Okay, first step is we start with those rows where no assignments have been made. So in this particular problem, it was the fifth row in which no assignment had been made. So we mark it with a tick mark here. Okay. In the marked row, we look for zeros, right? Now, wherever that 0 occurs, we mark the respective columns now, again with the tick, right? So we observe that there is only 1 0 here in the fourth column. So we mark the fourth column with a tick. Then we examine those marked columns. Right? But now we will look for those zeros that have been assigned, right? So in this column, I get 1 0 that has been assigned, and that happens for the fourth row. So I mark that fourth row with a tick mark again. Then I repeat the same procedure as I had done earlier for rows. So it's like rows, columns, rows, columns, till what? Till none of them can be marked, right? So like if I look at the fourth row again, I observe that there are 2 zeros in the first and the fourth column, right? The fourth column has already been marked, so I won't mark it again. But the first column had not been marked till now, so I mark the first column. Now again, I look for assigned zeros in the first column, and I observe that there is an assigned zero in the first column. And that happens for the second row. So I mark the second row. Now I look for zeros in that row. No more zero left, only 1 zero for which the column has already been marked. So that means in case there is no zero left, that means no column can be further marked. And if no column can be further marked, that means no more zero can be further marked. So that means the marking part completes until till we do not get any such zero here in this matrix itself. Is this clear? Okay. Now comes the fifth step. The fifth steps, what we have to do is we have to draw we have to draw straight lines through each marked column and unmarked row. Now remember this, straight lines through marked columns but unmarked rows. Okay, I have only 2 marked columns, so I'll draw a straight line from the first and the fourth column, right? Similarly, I have 2 unmarked rows, so I'll draw a straight line through the first row and the third row. This is clear? Straight lines vertical through 1 and 4 column and horizontal lines from A and C rows. Now we have got this. Okay. Now this is your, opportunity cost matrix on the process of reduction further. Okay. So now how to reduce comes your step number 5. Okay. So step number 4 is where we were drawing horizontal and vertical lines. But to draw horizontal and vertical lines, we needed which rows can be marked and which columns can be marked, because we need to differentiate. We had to cross only the marked columns and the unmarked rows. So before drawing those straight lines, we needed the marking procedure. So we have the marking procedure listed with us. Once we have, identified which rows and which columns have been crossed with horizontal and vertical lines, we move on to our step number 5, which is the process of revising the cost matrix. Okay. So I'll be writing the step number 5. This is slightly simple. Only step number 4 is tricky, where you have to remember things. So in step number 5, we are going to revise the cost matrix. Now, how do we do that? We look for the elements. Okay. So the first step here is from amongst the elements or the cells, whatever you want to call, for amongst the cells not covered by any lines. This is important. Okay. Not covered by any line. Choose the smallest. Okay, the minimum. From where that have not been covered by any line. Okay, we choose the smallest. Say, let's call that element as K. I'm calling it K. We'll come back to our problem later. Okay. Then what we do is subtract. Now, this is important to remember. Subtract this K from every element in the cell, in the table, not covered by any line. See, now this procedure is slightly similar to, like in transportation when we were making the allocations. We were subtracting something from certain cells and we were adding that same thing to some other cells. So same thing we are doing here. We are identifying from amongst the cells that have not been covered by any line. Okay. Once we have identified that element, we are subtracting that element from every element in the in the table which is not covered by any line. But at the same time, we are adding this K to every element that occurs at the intersection of two lines. Okay, because we have a crisscross of horizontal and vertical lines, definitely there are certain elements that are at the intersection of these two lines. Okay, so to those elements we add K. Okay, so we say add K to every element that occurs at the intersection of two lines. Okay, but of course then there would be, we have handled elements that were not covered by any of the line. We have handled elements that were covered by at the intersection of the two lines, but there would be elements that are covered by the line itself, not at the intersection. Okay, so we keep those elements unchanged. We say keep the other elements unchanged. Okay, and we get a new matrix now. Okay, that becomes your revised matrix, right? So we make the allocations again. Okay. So because see what will happen when you have subtracted K from other elements, that were not covered by any line, some of them will become zeros. So that means now you may have different zeros, right? Then there could be certain zeros which would occur at the intersection of lines. So what will happen? Those elements will not be zero anymore. They will now become K because we are adding K to it. So what will happen is that your distribution of zeros will change. Now, if distribution of zeros has changed, that means your assignments will change. Okay, so that means now we'll have to make new set of assignments. So it's like you are again in the background. It's something like you have identified your entering variable, you have identified your departing variables. So you have new set of allocations now. Okay, so that means we'll again start the allocation procedure and keep on checking the same things again and again. So that's why we say in the end we say that step number 5 is now we repeat steps 2 to 5. I mean, how did I write? We repeat steps 2 to 5 till an optimal solution is reached. Okay, so if we come back to our table, that the problem that we were solving, this is what we have got, okay, where we have drawn all horizontal and vertical lines and we have reached this stage. Okay, now see, you have 6, 15, 3, highlight it again. You have 6, you have 15, you have 3, then you have 4, 2, 5, 3, 5, 6, 8. They're not covered by any of the lines. Okay, so we have to identify the smallest amongst them. Okay, then you see 5 here. This occurs at the intersection of the first row and first column. Similarly, 10 here, it occurs at the intersection. 8 here. This 0, see, this 0 occurs at the intersection. So it will change. It will not be 0 anymore, right? But the other elements like 3, this 0, this 0, or this 0, or this 0, or this 0, they are not at the intersection and they're not even at a place where they're not covered. So that means they're not going to change. They will still remain the same, right? So from the other elements, we are going to subtract the smallest element. To elements at the intersection, we are going to add that smallest element and all other elements are going to remain the same. Okay. Now, if you look at the elements that have not been covered by any line, the smallest happens to be 2. Okay. So that means we have to subtract and we have to add 2 to wherever places it is required. Okay, so that means my table will now become, now you can start making another table with this procedure, the step number 5 that I have defined just for you. So I'll make another table now, and this, but we'll start putting in the values that we have to change. Okay, so 1, 2, 3, 4, and 5. So now we are going to make a revised cost matrix table. Okay, now see, the smallest element is 2. So in this case, my k happens to be 2. Okay, now the first element, 5. 5 was at the cross section. Okay, so that means this 5 will now get changed to 7 because I have to add 2 to 5, right? So this element now becomes 7. Okay. Now the second element was on the line, on the horizontal line, so it remains unchanged. Then 8 was also on the horizontal line, it remains unchanged. But then 10 was again at the cross section, intersection. So this 10 will now become 12 and 11 remains unchanged. This is clear. Okay. Now come to B, I mean B1. Now B1, because I had a vertical line passing from the first column, but no row passing through B, no line passing through B. So this 0 remains unchanged, right? Now the next element was 6, which was not covered by any line. So that means I have to subtract 2 from 6. So it becomes 4. Okay. Similarly, then next was 15. So again, I have to subtract 2. It becomes 13. Then the next was 10, which was on the line, vertical line, passing through 4, but not at the intersection. So it remains unchanged, 10. And then 3 was not covered by any line. So 3 minus 2 makes it 1. So this becomes my second row. Similarly, third row, 8. 8 was again at the cross section because I had a line passing through row C. So this becomes 10. 5 remains unchanged. 0 remains unchanged. But see, this 0 now becomes 2. And this 0 remains unchanged. Similarly, for fourth row, this 0 will remain unchanged. But this 4 will become 2. And this 2, mind you, see, becomes 0. Okay. So we have a new 0 here, which in the earlier table was not there. We had a 0 here, which has been removed, but then this 0, this 0 we have incorporated now because of this revision process. Then the next 0 will not be there and will not change. And then we have 5, we have 5, which will get changed to 3. Am I right? Because this 5 was not covered. So we have to subtract this 2 from this 5. Okay. So this becomes 3 now. Now in the last row, the 3 remains unchanged. Then 5 minus 2 again makes it 3. Then 6 minus 2, 4. This 0 remains unchanged. And then we have 8. Okay. Is this clear? Right.
Yes, ma'am.
Now
And
we
will the 8 not become 6 because it is not marked by any line?
Yeah. I'm sorry. This 8 becomes 6 because it has not been covered by any line. Right? So it becomes 6 now. Okay. Now we start the allocation procedure as we have done earlier. Right? We look at the rows which have exactly 1 0. Let's do it this way. Identify the rows that have exactly 1 0. My first row has 1 0. I mark. Right? My second row has 1 0. I mark. My third row has 2 zeros. I leave it for the time being. My fourth row has 3 zeros. I leave it for the time being. My fifth row has 1 zero. I mark. Okay. Do it this way. कोई गलती नहीं होगा कभी भी. Now let's see which zeros have to be crossed, striked off. Okay. This marked zero has no zero in the column, so no striking off required. This marked zero has a zero down, so I strike it off, right? This marked zero has a zero up, so I strike it off. Now this row is left only with 1 zero, so I mark. This zero has another zero here, I strike off. So this row is then left with only 1 zero to be marked. Is this okay? Now, how many marked zeros do I have? 1, 2, 3, 4, 5. So that becomes my optimal solution because my marked zeros is equal to the number of rows and columns. Okay, so no more revision required. I have reached optimality. And optimality means I can conclude that job A can be assigned to the second employee, job B can be assigned to the first employee, job C can be assigned to the fifth employee, and job D can be assigned to the third employee, and job E can be assigned to the fourth employee. So every job has been assigned and every employee has a job. Okay, and if you compute the cost, that will be your minimum cost of completion of this project. Okay, so this is how we solve these problems. और करना है? Shall we try some more? Because sometimes, sometimes it so happens that more than once you have to revise the table. So when you are trying out these problems, it could be that you have to make tables quite a number of times, but it's okay as long as it's giving you these solutions, right? So let's try this problem. Let's try one more problem. Shall we? I was just looking at another problem that. Yeah, let's try this problem. Supposing again I have 5 employees. Okay, and 5 jobs. And the cost matrix is something like this. The entries are, I'm just writing 2, 9, 2, 7, 1, and we have 6, 8, 7, 6, 1, 4, 6, 5, 3, 1, 4, 2, 7, 3, 1, 5, 3, 9, 5, 1. Okay. Now we have to assign the employees with the jobs. Okay. So what is the first step? We look for the smallest element in each row and subtract every element of that row with that. I'll have to move on. So let's see. No, I'm depending upon your calculations, okay? Because I can't scroll up and down. Now, what is the smallest element in the first row? 1. In fact, sub mein 1 hai, right? So we subtract 1 from each element of the first row. So it becomes 1, 8, 1, 6, 0. Am I right?
Yes, ma'am.
Then the second row also smallest is 1. So it becomes 5, 7, 6, 5, 0. Right? Then it becomes 3, 5, 4, 2, 0. And then 3, 1, 6, 2, 0. And then 4, 2, 8, 4, 0. Is this right? Because 1 is the smallest in each row. So you subtract 1 from each other element of that row. Okay. Now, once we have this, then we have to repeat the process for the columns. And as I can see, there is no 0 in the first 4 columns. So in fact, in the first column, again, the smallest is 1. In the second column, the smallest is 1. In the third column, the smallest is 1. But in the fourth column, the smallest is 2. Okay. So we repeat this process for each of the columns and we get a different matrix. Okay. So the matrix now will be A, B, C, D, E, and we have 1, 2, 3, 4, 5. Okay. Now we write column wise because we are subtracting from each column. So 1 is the smallest, so it becomes 0, 4, 2, 2, 3, right? Then we are going to have 7, 6, 4, 0, 1. Then we are going to have 0, 5, 3, 5, 7. Then 4, 3, 0, 0, 2. And then 0, 0, 0, 0, 0. Is that fine?
Yes, ma'am.
Yeah. Now we start the allocations, right? Now see. First row has 3 zeros. So no, I don't make an allocation right away. Second row has 1 0. Okay. So I mark a star. I mark it, right? Then I look at the third row. It has 2 zeros. But the moment I have marked this. I mean, it's up to you how you do it. Okay. So I've already striked them off. But then when I come to C, I observe that there is 1 0 left. I can mark this, strike it off, right? And then in this row, I can mark this. No other 0 left. Then suddenly I see that in my row number A, I have 2 zeros. Both of them can be marked. Okay. So it's a tie. So it's random. Okay. So I mark this and I have to strike off this. Is this okay? Right? Now this, as I say, you may start with anything, but in the end, even if you start, like you could have started with this, and striked it off. It doesn't matter. In the end, the optimal solution will be unique. You can try it yourself later on. Okay. Now I observe that this is not an optimal solution because the number of assignments is less than the number of rows and columns. So we have to start the marking procedure. Okay. Now we have to identify any row that has where no zeros have been assigned. Okay. First row, I have an assignment, second, third, fourth. So it's the fifth row which does not have an assignment. So I mark it with a star, with a tick. And in this fifth row, I have a 0. So I mark the fifth column also. In the fifth column, I have an assigned 0 in the second row. So I mark it, right? But in the second row, there is no other 0. Okay. So that means the marking stops. Is this okay? So, I mean, you can have minimum number of markings. It doesn't matter. Okay. Now we have to draw straight lines through each marked column and unmarked rows. Okay. So I just have one marked column. So I'll have only one vertical line. But I will have 1, 2, and 3 horizontal lines because I had 3 unmarked rows. Okay. Now we repeat the revision process. Okay. So we look for the smallest element amongst the elements that are not covered by any of the line, and the smallest happens to be 1 here. Okay. Which occurs at E2. So that means we have to, this 1 becomes our K. So I write here, that means my K is 1. Okay. So that means this 1 has to be subtracted from every element that has not been covered, added to every element that occurs at the intersection of the horizontal and the vertical lines, and the other elements, they remain unchanged. Okay. So we now start the procedure of revising our matrix. Now, I'll make again, we have now A, B, C, D, and E. Okay. And we had 1, 2, 3, 4, and 5. Now, what we'll do is look at the elements. First, 0 was not at the intersection, so it remains 0. Okay. Then 7 also was not at the intersection. This is 7. Then again, a 0 was not at the intersection. 0, 4, again same. But then this 0 was at the intersection. So we add 1 to it. It becomes 1. Similarly, the second row now becomes, because 4 was not covered, so it becomes 3. Then 6 minus 1 becomes 5. 5 minus 1 becomes 4. 3 minus 1 becomes 2. And this 0 does not change because it was not at the intersection. Then this 2 remains unchanged. 2, 4 remains unchanged. 3 remains unchanged. 0 remains unchanged, but then this 0 becomes 1. Right? Similarly, in the fourth row, because it was striked off by a line, so 2 remains unchanged, 0 remains unchanged, 5 remains unchanged. This 0 also remains unchanged, but this 0 becomes 1. Okay. Then the fifth row was not covered, so this 3 becomes 2. Okay. And this 1, we had a 1 here, so 1 minus 1 will make it 0. Then 7 minus 1 makes it 6. 2 minus 1 makes it 1. And this 0 remains unchanged. Okay. So this is my revised matrix now. Now again I start the allocations. So first row has 2 zeros. I don't do anything. Second row has 1 0. I mark it and I strike off this. My third row has 1 0. So I mark it, I strike off this. My fourth row has 1, 0. I mark it, I strike off this. Now again there is a tie. Okay, let me change. I do this. Okay. Now again, this is not optimal because again I have number of assignments as 4, but the number of rows and columns are still 5. So again we repeat the process. But now what I observe is we repeat the process of markings now. And what I observe is that, oh, I'm sorry. Let's start the markings. Just a minute. Yeah. No assignment in the 5th row, so I mark it with a tick. 5th row has to be marked with a tick. Now I have 2 zeros. This was striped off, right? Now I have 2 zeros in the 5th row, so I mark those columns also with a tick, right? In this column, second column, I have an assigned 0, so I mark here. And in the 5th column also, I have an assigned 0, so I mark here, right? Now identify the newly marked rows. In the 4th row, I have a 0, so I mark here. In this second row, no other 0. In the 4th column, I have a 0 assigned, so I mark this. Now no 0 here. That's it. Is it clear? So now you have 4 rows marked and 3 columns marked. Is it clear? Okay. So now draw vertical lines through each marked column. Right? We have this, and horizontal line through each unmarked row. You have this now. Okay. Now identify the smallest element from the others. Repeat this process, and you'll get an optimal solution now. I'm telling you. That will be the optimal. So try it yourself now. Okay. So this is how we solve assignment problems. Okay.